All right. Ooh, I don't know where my thing went. There we go. Bell work. Number 1, we want to select all exponential functions. First, before we select all the exponential functions, I want to know, how do we know if something is an exponential function? What has to be true for it to be an exponential function? Guys, you have a quiz tomorrow. Look at your paper down at the bottom. You have a quiz tomorrow. I need you to participate, and we got to get through this. I want to make sure that you are set up well for your quiz tomorrow because it's open notes. It is open notes, but I want to make sure that you're paying attention. You've got all the important information that you need so that you can be successful. How do we know if something is an exponential function? They asked us to select all the exponential functions, but I got to know what I'm looking for. An exponent. What about the exponent has to be true? Question. Is that an exponential function? No. This is not exponential. Not an exponential function. Why is it not an exponential function? I agree it has an exponent, but it's not a function. Because there's no x. Where does the x have to be for it to be an exponential function? Has to be part of the exponent. So if I had this, would that be an exponential function? Yes. This one is an exponential function. In order for it to be an exponential function, there has to be a base with an exponent that either is or has a variable. If the exponent does not have a variable with it or in it, then it's exponential, but it's not an exponential function. Do you guys understand the difference between those two? Okay. So with that in mind, is this first one, f of x, is that an exponential function? Yes. What about the next one over, g of x? Is that an exponential function? Yes. H of x? Yes. J of x? Yes. K of x? Yes. And finally, m of x? Yes. So all of the ones that were up here were exponential functions. I'm going to pick a couple out randomly. And I want you to tell me whether they're growth or decay. J of x, is that growth or decay? Ooh, I got both answers. What are we looking for? It's decay because the base is smaller than 1, yes. So this one is showing me decay. This base, when we're talking about a decay function, what else did we call the base? It had another name too when we were talking about this yesterday. The decay factor. The decay factor will be less than 1. What about if it's bigger than 1? Would we still call it a decay factor? No. What percent is this decaying by? It's not 20%. No. Remember how we had the decay factor written? It was 1 minus R. R is our rate. This is where we look for our percent. So how could I figure out what R is if all I have is this? Well, 1 minus R gave me a result of what? Yeah, gave me a result of 0.2. So what would R have to be? 0.8. 1 minus 0.8 gives me 0.2. We're finding the percent of decay. We're going backwards. 1 minus R gave us 0.2 because that's right there. Trying to figure out what would give you 1 minus what gives you 0.2. That'd be 0.8. Is this a percent? How do I make it so that I have the percent sign on the end of it? What do I need to do to that 0.8 to give it its percent? Multiply it by 100, yes. 0.8 times 100% means my decay percent is how much? 80%. So it is decreasing by 80%. Let's try another one where we find the percent, okay? Look at K of x. Is that one showing me growth or decay? This one is growth. How do we know it's growth again? Because it's bigger than 1. So this one is growth. What do we call this? The growth factor. This will be bigger than 1, greater than 1. So a decay factor will be smaller than 1, a growth factor will be bigger than 1. What percent is it growing by? What percent is it growing by? Close. You're very close, Precious. 2%. How do we find a growth factor? What did this look like? Was it 1 minus R like the decay? 1 plus R. Well, when we did 1 plus R, it gave us what? Yeah, 1.02. So R would have to be what? 0.02. And then to take that and make it into a percent, I multiply it by 100%, and we get 2%. So this is increasing, because it's growth, by 2%. Is it making a tiny bit more sense than the first one? Let's try another one. Let's look at m of x. Is this one showing me growth or decay? Be very careful. Decay. Why? We have a negative exponent. How could I rewrite this? What does a negative exponent do? Fraction. How would you write it as a fraction then? 1 over 3 to the power of x. If it has a negative exponent, you need to write the base as a fraction because x should not be negative. 1 over 3. So this is showing us decay. Be very careful about that. What is my decay percent? We know 1 minus r would give me that decay factor right here. So it would be equal to 1/3. What would r have to be to make that true? 2/3. R is equal to 2/3. What's 2/3 as a decimal? Yeah, it's 0.66 repeating, right? You guys okay if I write that as 0.67, so we just round it? Is that okay? So what is the percent of decay? 67%. This is decreasing by 67%. Super important that you take the time to write down what we're doing. I want to make sure that you guys are as prepared as possible for the quiz tomorrow. And since you get to use your notes, including your bell work, write down as much as you can so that you are ready for that. You got your bell work, sir? All right, pull your bell work page out. You can snap a picture of what's up on the screen if that's helpful. What does exponential growth look like when we were graphing it? It goes up. So does it start high or start low? Start low, but it's never below what? Never below 0. So exponential growth was looking like this. So what did exponential decay look like then? What do you mean by the opposite? I like it. Starts high and goes down, but still never crosses 0. What do you notice when you compare these two? They're flipped. Over what? Over the y-axis. So decay is a reflection over the y-axis. Decay is a reflection over the y-axis. So far, so good? All right. We're going to be in that extra notes packet that you guys should have picked up at the front of the room. We are going to learn how to solve exponential equations. You need to put that away, sweetheart. Put that away for me, please. Key concept for our first example. Ooh, and look, they even defined it for us right here. In an exponential equation, the independent variable is an exponent. If I have two exponential equations and they have the same base, then their exponents would also have to be equal. If I have the same base on the left and the same base on the right, then the exponents have to be equal. Yes, ma'am. A thin marker. I don't know how thin it is, but I got this guy. Okay. You're welcome. If my bases are different, then my exponents aren't going to be equal. But if my bases are the same, then those exponents are going to be equal. You need to put that away, dear. You need to take notes with us. I want to look at how this works with a problem. I'm going to do one like in between these first so that hopefully it makes a little bit more sense. If I have 4 to the x plus 1 equals 4 to the 2x, are my bases the same? Yes. These are the same base. So what would have to be true about their exponents then? They should be the same, or they should be equal to each other. So I could rewrite this whole problem since my bases are the same. I know these exponents also have to be the same. Can I solve that for x now? What would I need to do to solve it for x? Minus x, because I need to get my x's to the same side, minus x from both sides, and then 1 equals x. What happens if I take 1 and I put it in the place of x over here? It equals 2, so I have 4 squared, right? What happens if I take 1 and I put it in the place of x over here? I get 2, so 4 squared equals 4 squared. Does that make sense? Yes. Yes, ma'am. Huh? 2x minus 1x gives us 1x. We subtracted one of those x's off. All right, so I'm going to write down what we just did when we checked this. We have 4 to the x plus 1 equals 4 to the 2x. So I get 4 to the power of 2 equals 4 to the power of 2. And that is true. Yes, ma'am. This is just an example off to the side. I'm sorry, yeah, I put this just right in the middle. I should have had this as an example, but it didn't get printed. So now we're going to go look at example A, because do my bases match on example A?
No.
No. So I can't just take those exponents and set them equal.
My question.
Yes.
Can you make the bases match?
Can we make the bases match? Yes, we can. Yes, we can. Let's look at that bigger base. Look at the 64. (64) is equal to, we want to try to rewrite this as something to a power so that I can make those bases match. Yes, ma'am.
Wait, no, that's not right.
What are you thinking?
I was going to say 4 to the 16th power, but that's not right because you're multiplying.
Ooh, I like your idea though. You said this is 4 times 16?
Yeah.
Yeah, let me write that a little bit better. So 64 is equal to 4 times 16, which is not 4 to the 16th power, but I think we're on the right path because there's a 4 And there's a 4 right here, right? Can I break down this 16? 16 is what times what? So 64 equals 4 times 4 times 4. What'd you say? 4 to the third power. 64 equals 4 to the third power. Beautiful. So I can take this right here, and it can take the place of the 64 there. 4 to the third power is exactly the same as 64. So I'm going to replace the 64 here. We're going to rewrite this as 4 to the third power. Let me shrink down the rest of my writing over here. There we go. Get that out of the way. What about that 7? Well, that 7 was a power on the 64, right? It's going to go right here. Because what's inside the parentheses is exactly the same as that 64, correct? It's just another way of writing that number. The other side of the equal sign I'm going to bring straight down. So we have 4 to the power of 5x plus 1. Do my bases match now? Yes. Oh my goodness. Come on. Same base. So what does that mean about my exponents? They are equal. Well, here's the exponent on this side, 5x plus 1. And it is equal to, oh, on the other side, what's my exponent? I have a 7, but I also have a 3. 21. We multiply these together. We do 3 times 7. So 5x plus 1 equals 21. What can I do now to get x alone? Minus 1 from both sides. So that would be 5x equals what? 5x equals 20. Head up for me, sir. Stay with me. Divide both sides by 5, and so x is what? X is 4. Love it. Do my bases match here? No. What about, I'm going to do another example problem off to the side so we can try to get the big idea before we do B. You guys okay with that? All right, I'm going to put it off in its own little bubble. One over 7 to the power of 3x equals 7 to the power of 4. Do those have the same base? No. Is there a way that I could maybe rewrite this fraction so that it would be the same base? 7 to what power gives me 1/7? Negative what? Negative 1. So 7 to the negative 1 is another way of writing 1/7. And then to the 3x equals 7 to the 4th power. I'm going to need a bigger bubble here. Do the bases match now? Yes. Same base. So what's true about the exponents then? They're going to be equal. What do I do with these? Because I got two of them. Multiply them. So I have negative 1 times 3x is equal to 4. Yep, I got him. Negative 1 right here times 3x right there. So that gives me negative 3x equals the exponent on the other side, 4. So what would x have to be then? Yes, x equals 4 over negative 3. Let's try that same idea over here with part B. How could I rewrite a base of 1/2? Woo, bless you. Are you okay? Yes, ma'am. Dividing both sides by negative 3. You divide both sides by negative 3. I just didn't write that step in. I'm sorry. I was running out of room. Woo. So I can replace the 1/2 with what? 2 to the negative 1 can take the place of the 1/2. And what kind of exponent do I need on the outside of that? 4x minus 16, yes. Equals, well, now I'm coming over here. What? There we go. I don't know what that was about, sorry. It's possessed, sorry. You scared the board. What do I want this base to be? 2. 2 to what power gives me 16? 2 to the 4th power gives me 16. So I'm going to rewrite this as 2 to the 4th power. And then I have an exponent on the outside of that. What is it? 2x minus 5. Are my bases the same? Yes. Same base. Yes. Over here, let me change to something that's not red. Over on the left, right here, that negative 1 has to get distributed to both pieces. So I have negative 1 that gets distributed to 4x minus 16. What about over here on the right? The 4 gets distributed. So I have 4 times 2x minus 5. So I'm going to distribute those pieces now. I would have negative 4x plus 16 equals 8x minus what? Minus 20. What are we trying to solve for here? X. Where is x? Both sides. I need them on just one side if I'm going to isolate it and get it alone. How do I get the x's just to one side? We could add 4x to both sides, or we could do what? Subtract 8x from both sides. You got to do it. It doesn't matter which one you do. I heard people showing a preference for this one, so let's add 4x to both sides. But you could also minus 8x. So I have 16 equals what? 12x minus 20. What would I do next? Add 20 to both sides. I don't want to subtract the 16 because I want all my x's to one side, which I did, and then I want everything else on the other side. What is 16 plus 20? 16 plus 20. 36. 36 equals 12x. And then what do I need to do to get x all alone? Divide by 12 on both sides. 3 is absolutely correct. 3 equals x. So far, so good? Okay, so the goal is to make the two bases match. Sometimes we have to change both numbers like we did on this one. Sometimes we only have to change one of them. Let's look at example C. Let's try this one last time. Are my bases the same? Not at all. Okay. What can we do? Because I need to try to make them match. Tell me a way that we could rewrite, say, 81.
You read to the fourth.
Ooh, I heard 9 times 9, so 9 squared. And I also heard 3 to the fourth. Tell me why you thought of 3 to the fourth. Like, what was it that made you go after 3 to the fourth versus 9 squared?
Because you can't times 9 times a second get 27.
Yeah, I can't do 9 to some power and get 27. But 27 is 3 times 9, right? And then I can break down that 9 a little bit more to be 3 times what? 3 times 3 times 3, yes. So 27 is 3 to what power? 3 to the third power. So I can rewrite this one. Why do we have to rewrite them both? Okay, you answered your own question. That works. All right, so Jaden was pointing out that we can't rewrite the 27 as 9 to a power, but I can rewrite 81 as 3 to a power. Because I've got 3 times 3 from this 9, and I have another 3 times 3 from this 9. So 81 is 3 to the fourth. So I'm going to rewrite 81 as 3 to the fourth power. And then we got to bring down that exponent, x minus 5. Do my bases match now?
Yeah.
Yes. Same base.
I have a question.
Yes.
So we don't need to solve for one of the x's.
We have to get the x's on the same side of the equal sign. And so you'll only have one x at the end. If you still have 2 x's, then you didn't combine them together the way you needed to. Yep. What do I do over here with these exponents? Yep, we multiply the 3 by the 2x. What else? We still have to distribute this guy. We have to distribute that inside exponent, the 3, to both of the pieces that were already the exponent. Over on the right, what do I need to do? Four times x and 4 times negative 5, yes. So 4 times x minus 5. Then I'm going to show my distributing work. Nope, if you distribute in your head and you write down what it is, that's fine. Just don't forget to distribute. 6x plus 18 equals 4x minus 20. You're absolutely correct. Where is x? It's on both sides. It's on the left and it's on the right. I need to get it to just one side, so I have to make one of them cancel out. We could do minus 4x on both sides, or we could do what? Minus 6x on both sides. As long as one of them cancels out, you are fine. I heard minus 4x first, so that's what we're going to do. Is that okay? Either way is fine. So I have 2x plus 18 equals negative 20. I want to get the x all alone, so that means I need to get rid of that minus 20. How do I make a minus 20 cancel? Sorry, plus 20. Ugh. It says, oh my goodness. It says plus 18 and minus 20. I want to get the x alone. It's over on the left right now. Minus 18, thank you. It helps if I look at the problem before I speak. We're going to minus 18 on both sides. What is negative 20 minus 18? Negative 38. Is x alone yet? What do I still need to do? We're almost there. Divide both sides by 2. And so x is negative 19. Beautiful. All right. We are going to do a story problem now. Next page. That'll be the last thing that we do for today, though. Flip the page for me. Solving an exponential equation. We were solving exponential equations before, but this one's in a story problem. Since the Super Bowl began in 1966, the extremely high viewership, a lot of people are watching, of the Super Bowl has led companies to pay millions of dollars to advertise just 30 seconds. They pay millions and millions of dollars for a 30-second Super Bowl ad. The average cost of a 30-second advertisement during the Super Bowl can be approximately modeled by an exponential function, where the initial cost is how much? $58,000. That's my initial amount, so that is little a. The average cost increases by what? 9.9%. What are they telling me there? The rate. Can I put it like this into my problem?
No, you gotta make the 9.9%.
Yep, 9.9%. How do I change it into a number without a percent sign? Divide it by 100%. So that makes my percent signs cancel out. What do I get when I divide those two? Close. 0.099. This is R. All right, I want to substitute in. They're not using big A. They chose to use the letter C. Yeah, they just use C for cost instead of big A for amount. But it means the same thing. So we're going to have C equals. What are we putting in for A? $58,000. That's, by the way, how much it cost for a 30-second Super Bowl ad in the very first Super Bowl. They paid $58,000 for one 30-second ad. And then inside the parentheses, I have 1 plus 0.099 to the power of x. We don't have a t anymore. Why did they use x? What is that meaning? Look at the text just above it. C be the average cost of a 30-second ad, and
X be the number of the Super
X be the number of the Super Bowl. Does anybody know what the number of the Super Bowl coming up is? I don't know off the top of my head either. I know we're well past the first Super Bowl, right? I know we're not all the way to the 100th Super Bowl yet.
50,
I think it's 50 or 60 something. I'll have to look it up. I know they just decided the teams that are going to it last weekend. So X is the number of the Super Bowl. I want you guys to help me figure out when the cost for a 30-second ad got to $1 million. So I'm going to put 1 million in the place of C. 1 million. How many zeros does 1 million have? 6 zeros. 1 million equals 58,000 times 1 plus 0.099 to the power of x.
0.099.
What'd you say?
Can I just put 0.099?
Is 0.099, oh, as opposed to putting the 0 in front of it? Yeah, that's fine. I write it like this. I always put that 0 and then the point so you can always see where the point is. Yes, ma'am.
This is the 58th Super Bowl.
It's the 58th?
Yeah.
58th Super Bowl. And it costs a ton of money for those ads that they run during the Super Bowl. I'm going to bring this around over here. Can I add the numbers inside the parentheses together?
Yes.
Yes. So I would have 1 million equals the starting amount, 58,000, times what? What goes in the parentheses? 1.099 when I add those together to the power of x. Did it do it again? No. All right. Here's what I want you to do. And if you do not have a calculator in front of you, please come grab one. We're going to do some guess and check with the calculator. And I got prizes for whoever gets the closest. You're going to put this side in the calculator. You choose a number for x.
Oh, no. How are we supposed to figure that out?
Well, hold on. You're going to have to do a lot of guess and check. You're trying to get as close as possible to 1 million. Try to get as close as possible to 1 million, because we want to know where this equals 1 million. I got prizes for whoever can get the closest. You got to pick some x's out and plug them in. You're plugging numbers in for x, yes.
Can the numbers be decimal?
Yes, they can.
Oh, okay.
So you can't get over 1 million?
I want you to get as close as possible to 1 million. If you go a little bit over 1 million, but it's still really, really, really close, I want to know what that number is. I want to know what you put in for x to get there. You got one?
I'm waiting.
You got 31?
30.
Oh, we got somebody that says 30. Can we get closer than 30 or 31?
31 for X.
Can we get closer to 1 million by trying numbers other than 30 or 31? We want to get as close as possible. You said what?
30.5.
30.5. Can you get closer? $30.2. Can you get closer? 30.36. Try to get as close as you can to a million exactly. Okay, so you're over a million. Because a million would have 1 and then 6 zeros. You're almost at 2 million there. Right, 30, I think 30.2 is the closest we've gotten so far. 30.17. Can we get closer? 35 is going to be too big. Can we get closer than 30.17?
34.
Still too big. Because 30 was too small and 31 was too big.
Okay.
So we're trying numbers in between 30 and 31. I think
30.
the closest that there are 30.12. 30.165. I think that's probably the closest we're going to be able to get. We could go for, I think we're good to stop. Jaden, you also got very close. Sawyer and Jaden, you guys.
What's the answer for?
We had a 30.165 here, and what was the closest one that you said?
I had 30.12 as well, but I had 30.7.
Come up and get one too. Yeah, I thought you said 30.17. 30.165 was the closest we could get with guessing and checking with the calculator. Getting closer and closer and closer. Is there a Super Bowl 30.165? No. Was there a Super Bowl 30? Yeah. Pop that into your calculator. Put 30 in for X. Just read off the numbers. That's fine. 984,826, you said?
4.
Okay. So that's a little bit below a million, right? So in Super Bowl 30, it still wasn't quite $1 million. What about in Super Bowl 31? What was it in Super Bowl 31? Did it go over $1 million there?
Yeah.
So it's over $1 million in Super Bowl 31, but it's under $1 million. So somewhere in between those two is when we topped $1 million. Since we can't actually have a Super Bowl 30.165, that doesn't make sense. They don't do Super Bowls but once a year. Does that make sense? So in between these two Super Bowl years is when it got over $1 million for 30-second ad. So we've talked today about two different ways to solve exponential equations. There is, if you can, you're going to rewrite the bases so that they're the same. Here, I had a base of 1.099. There was no way I was going to be able to write 1 million as 1.099 to some power. So I just tried some guess and check on my calculator for that one. We are going to stop here for today. I want to talk to you briefly before the bell about what tomorrow looks like. Yes, ma'am.
Did you get a homework packet yesterday?
I passed out. Oh, the 7.2 homework is just a McGraw-Hill homework, and I'll put up on the board what those problems are, so that you can start on those. And we just started that today. So this is the new homework starting today. It'll be due on Wednesday next week. Because tomorrow, the only thing you guys are doing is the skills check. Open notes skills check. I want to make sure that you have plenty of time to get it finished. That one is due tomorrow. 7.1 Part 2 homework is due tomorrow. 7-2 homework is on McGraw-Hill and it's due next week. The 7-1 homework is extra credit if you want to do it. The McGraw-Hill 7-1. We're going to finish up this extra notes packet on Monday because tomorrow you'll have the whole class period to work on that skills check. I want to make sure that everybody gets done, everybody has plenty of time. Things that you need to turn in tomorrow. You need to turn in the skills check when you're done with it. You need to turn in your bell work page tomorrow. I know we're done with the bell work page, but I want you to have it to be able to use on that skills check as part of your notes. You can use any other notes that we've taken, whether it was on extra notes pages or in your book. So you'll turn in your skills check. You'll turn in your bell work. And you'll turn in your 7-1 Part 2 paper homework. All right. The homework that is due on Wednesday. It's pages 369 to 370. Numbers 1 through 3, 6, 11 and 12, 21, 27, 31, 35, and 39. Not due till Wednesday next week. Does anybody have any questions about what tomorrow looks like or what Monday looks like? Tomorrow's skills check, turning in work. If you get done with the skills check before the end of the period, you can work on homework, you can work on something for another class, you can work quietly. But there will be nothing else that you need to turn into me or do for class tomorrow except the skills check. All right? It's one piece of paper. There are problems on the front and the back, but it's just one piece of paper. And then on Monday, we'll finish out the notes packet.